Hey guys, this week is all about air pressure. We talked a little bit about air pressure in the fall during hurricane season, but I love talking about it in the spring because the weather really is kind of changing every day. Some days it's hot out, some days it's cold out, some days it rains all day, other days it thunderstorms. And so it's really kind of an exciting time to be talking about weather and things like air pressure. So, um, if you are at the point of this video, that means that you have completed all your water cycle assignments and you have started the tech book from yesterday, because those are going to be helpful things to know moving forward to air pressure. So air, just like any other form of matter, has a mass. So air is matter, and anything that is matter has a mass to it. So um, I love this cartoon because we don't really ever think about air having a weight, because we feel it all the time. If you think about um, other than being in a pool and being in water, we air is always around us. So we're very used to the feeling of air. However, if you go to different places, or if there's a change in temperature, a change in elevation, the air pressure is going to change with it. So this cartoon is always fun to get us started. But at this point, I would like you, if you haven't already, to take out your notes. And if you've already taken notes on air pressure, if you could open up to those and then just follow along and add anything as needed as I talk today. If you do not have your science journal, if you've not taken notes on air pressure yet, that is definitely okay too. Please just get out a sheet of paper or Google Docs. And you really want to write down a lot of these definitions. So air pressure is the measure of the force with which air molecules push on a surface. So like I kind of hinted at before, depending on where you are in the earth and depending on the temperature, uh, air is going to be pushed. Gravity is always pushing the same, but there's sometimes going to be more air in a certain area for gravity to push than in other areas. Um, so an area that has high air pressure, you can kind of see in this diagram here, an area with high air pressure is going to have more of these dots, and these dots are representative of air molecules. So there's going to be more air molecules around an area of high pressure than an area of low pressure. Think about low meaning less. There's going to be less air molecules represented by these little dots here. Less air molecules, less air being pushed down on you in a um, low pressure area. So air pressure is greatest at the surface because that is where more of the most amount of atmosphere there is to push down on you. So if you think about um, if anybody's ever done one of those human pyramids, um, the people at the bottom of like where you make a pyramid out of a bunch of people, the people who are at the bottom of the pyramid feel a lot of weight on their back. The people at the top of the pyramid feel less weight, and that's exactly how air is. Um, at the atmosphere, at the Earth's surface where we are, we feel much more air than if you go way up high in the atmosphere, because there's less air to be pushed down on you. Air pressure is dependent on density. Let's kind of think about the word density for a second. Density basically means the amount of matter in a given area. So air pressure is completely based off of how much matter, in this case, how much air is in a given area. So kind of like we said on the last slide, more dense air will have a higher air pressure. There are more air molecules in that space to push down on you. So here we have a little bit more of a detailed, I wouldn't say detailed, more of a specific drawing of the air molecules in a high pressure area. So more density means there's more air molecules pushing down on you. Less dense air will give you lower air pressure because there's going to be less air molecules pushing down on you. So this is just kind of a good way of thinking about it. If we think about like, I always like to use our classroom as an example. Um, if we filled up our classroom with just, let's say we got our class in there, Miss Harper's class in there, um, Miss Sketch's class, Mr. Pulowski, Miss Balcomb's class, they all came in. That would be like a high pressure area because there's going to be a lot of density, a lot of people inside that given area. Um, then let's say I said, okay, numbers 1 through 5 stay in the class, but everybody else um, find another classroom to go into. That would be a less dense area because there's less people in the room. So we think about density. I like to a lot of times think about it in the sense of our classroom buildings. Not necessarily that there's less people in the school, there's just less people in our classroom in a less dense situation. All right, so air pressure is affected by 3 factors. Elevation or altitude. This is how high you are up in the sky. So Wilmington we call that basically at sea level. So I think where I live, and I live really close to the ocean, is like 2 or 3 feet above sea level. If you go somewhere like I love going to Asheville. If you go to Asheville, they're thousands of feet above sea level. So they're actually really closer to space than we are, not by in relatively speaking. But the higher you go up, the more elevation you increase by. So if we think about a pyramid or like one of those human pyramids where there's like 4 or 5 people on the bottom of it, and maybe 4 people in the next row, 3 on the next, 2, and then 1. The higher you go up in the pyramid, the less weight people are going to feel on their backs. And I'll attach a picture. It's going to be kind of silly out of context, but I'll attach a picture onto the Google slide or the Google Classroom page with the human pyramid that I'm talking about. Because if you have no idea what I'm talking about, it's probably hard to visualize based off of my description, but I'll attach that picture on there. Then temperature. So we talked a lot about when we were talking about heat transfer. Hotter things are lighter because if you think about when you're really hot, you like to kind of spread out, and that's exactly how air is. So temperature is going to have a great play on air pressure too. Then if you think about something being cooler, when you're cold, you like to kind of bundle up. Air likes to bundle up together too, and so there's going to be more dense areas where of colder air, and then less dense areas when there's warmer air. Then water content. This is the amount of water that's in the air. So a lot of times air is filled with oxygen, carbon dioxide, things like that. But there's, especially in Wilmington where it's humid all the time, there's water that takes up the space of air. So if there's water taking the place of air, there's going to be less room for air, making it less dense. Okay, so here's kind of a example of what I was talking about with elevation. So if we were in Wilmington, kind of where I'm pointing my mouse right now, very low in altitude from sea level, we are experiencing all this air above us, all this blue air, all this uh, kind of lighter color. And of course, air is not actually that color. This is just a picture. But we're experiencing all the pressure from that. As you go up, you're experiencing less and less pressure. So if you climb Mount Everest, you'd have a lot less pressure, a lot less air pressing down on you than you would if you're down here. There's just that much more air. So as you increase, as you go up, the air pressure decreases or gets less. So make sure you put that in your notes. As you move up through the atmosphere, air pressure decreases because there's less of it to be pushed down on you. Again, I am going through this PowerPoint very quickly. The nice advantage of doing this from your home is you can pause it, you can go back. So if you want to pause, put this in your notes. I suggest doing that. And then once you're ready, hit play. We'll move on. All right. So the impact of elevation on air pressure. The last slide said as you move up, air pressure decreases. So it kind of works like a seesaw or teeter-totter. One person goes up, the other goes down. Air pressure is on one side of the teeter-totter. Air pressure is on one side, elevation on the other. If your elevation's up, air pressure's down. If elevation decreases, air pressure increases. So they kind of move at opposites. There are fewer air molecules above you to push down on you, so the force of the air is going to be less. This picture does kind of a good job depicting this. The MB is a unit of the amount of pressure, the millibars, the amount of pressure that's being pushed down on you. So at sea level, and this is honestly where Wilmington is, in this given picture, the air pressure is at 1,008 millibars. At station B, you climb up the mountain a little bit, the air pressure decreases. Now it's at 915. And at station C, you climb even further up. You're about 1,800 meters up. The air pressure is at its lowest, and it's at 840 millibars. So this is just a good example of as you increase, the more pressure on you. Just like if we were thinking about water, as you get deeper in the water, there's going to be more water pushing down you. Air is the same way. Okay, so the impact of water content or humidity on air pressure. Just like in class, I still have to take a sip of my coffee when I'm talking. Moist air is less dense than dry air, therefore it has lower pressure. A water molecule has less mass than other molecules that make up the air. If you replace some of the air molecules with water molecules, and the water lowers the density and lowers the air pressure. So let's think back to my example of our classroom. Let's say we had all the fifth graders in my classroom again. Very dense. My classroom would be very dense. It'd be full of students. Then I said, okay, Miss Balcom's class, Mr. Pulowski, Miss Harper, and Miss Sketch's class, you guys go back to your classroom and let's bring in the same amount of students, but let's bring in kindergartners. So let's bring in maybe Miss Arcieri, Miss Matthews, Miss just all the kindergarten teachers. I'm blanking on a lot of their last names right now. Miss Gold. If we brought in 4 kindergarten classes rather than 4 fifth grade, there would still be a lot of people in the classroom. But then if we represented us as fifth graders represented the air pressure, and we said, okay, fifth graders, you represent air pressure. Obviously, a lot of air pressure left and was replaced by the kindergartners, which could say, okay, kindergartners, you represent water. So the water when we have water in the air, it takes out or kind of spreads out the air. So once water's in the air pressure is going to decrease. So if you go outside on a really humid day, what has happened is a lot of the water has evaporated from the ocean and is now in the air, and that's going to kick out some of the air molecules. So kind of clear some room out for the water. So it's going to be less dense. You're going to have less, if it's humid out, you have less air pressure. All right, and then the last thing we want to think about is temperature. So warm air is less dense than cold air, therefore warm air has lower air pressure and cold air has higher air pressure. So again, if you kind of think about air, if it gets hot, it likes to spread out. When air is hot, it spreads out. When air is cold, it bunches up, and it's kind of shown in these models down here. And somebody could tell me how to get rid of this dang thing here. I'd love to get rid of this. But this is a great example of all the dots here again representing the air particles, and all the dots here representing the air particles. There's much more air particles bunched together in cold air, because think about air is getting cold, it likes to bundle up. When air gets warm, it likes to spread out. So kind of to recap, I want to go back and talk about this again. If you increase any one of these 3 things, if you increase elevation, temperature, elevation, fancy word saying height, temperature, water content, or humidity, the air pressure is going to decrease. So we think about it on like a seesaw. Air pressure, the higher these go, the lower the air pressure goes. The lower these go, so if you drop the temperature, if you drop the water content, the air pressure in an area is going to increase. So these work exactly opposite. So low elevation means high air pressure, or means higher than usual air pressure. Lower temperatures, the higher the air pressure. Lower water content, the higher the air pressure. Okay, So we use something called a barometer to measure the air pressure, and there's different types of barometers. This one here really measures the weight or the mass of the air, and so if there's more air pulling down on it, it's going to move the needle higher. These ones, the mercury barometers, they represent when air gets pushed down into the tube there, the this color rises. Basically, how that works. But the main thing you need to know for this slide is a barometer is a tool that we use to measure air. So there are lots of different weather tools. The barometer measures air pressure. All right, and this is kind of a better explanation of what I just said about the mercury barometer. All right, so we talked about what causes different air pressure, what causes changes in air pressure. Now let's talk about what weather is affected by the air, how weather is affected by the air pressure. So air pressure in a weather system reflects the amount of water in air, which affects the weather. So if somewhere is in low air pressure, that means there's a lot of room for water to take up the air, or water has taken up the air. So this a lot of times will give you stormy or cloudy weather, um, like a day where it's raining all day or a day where it's thunderstorming. That's usually going to be a result of the air pressure dropping. So air pressure drops. A lot of times storms come in, clouds come in, it's overcast. Air pressure rises. A lot of times that brings clear skies, no precipitation. That being said, a lot of times when the temperature decreases, air pressure increases. So cooler temperatures are usually associated with high air pressure. Lower temperatures or higher temperatures, like hot temperatures, are associated with low pressure. That's something that I would say most fifth graders get confused with because they say, "Oh, low air pressure, that means low temperature," where it's actually the opposite. Low air pressure, higher temperatures. So it's going to be a little bit hotter out with low air pressure. It's going to be a little bit cooler out with higher air pressure. So think kind of the opposite with temperature. All right. On weather maps on the tech book that you got on Monday, we introduced weather maps a little bit. So weather maps show air pressure by the H and the L. H is always representing high pressure. L is always representing the low pressure. Remember, with high pressure, these areas are experiencing a lot of dry weather and this is not always the case. So it's not always, oh, right outside the coast of California, it's always high pressure. This is just that given day, whatever weather. This is an example of it. So Wednesday, whatever Wednesday they're reporting this. These areas are dry and it's probably sunny out. Maybe the temperature is a little bit lower than usual. These areas with the L in it, they're experiencing, look at this, some precipitation here, some snow and showers. Something I do want to point out is I just said an increase in temperature decreases air pressure. It doesn't have to be, it doesn't necessarily mean if there's low pressure that it's going to be 80 degrees outside. All that means is, let's say this is an area of Canada where it's usually pretty cold. All that means is going to be less cold. So, in this situation, you can have, maybe it was 20 degrees all week and now it's 30 degrees. So it's not really bringing warm weather, it's bringing less cold weather. So that's why there's snow in a low pressure area. Over here, you have rain, thunderstorms, again, all in a low pressure area. So over here, again, the snow, this is in Canada once again. So again, it's cold, but it's probably less cold than before. So I know that gets a little bit confusing, but just think of air pressure. Low means less cold. High means it's usually a little bit cooler. Not necessarily cold, but cooler. So we could have a high pressure day in the summer and it's not going to start snowing on us. It might just go from being 90 degrees to 85 degrees or something. But just because something is the air pressure is dropping, the temperature is not going to increase just so significantly that it's going to bring a whole different set of weather. Okay. That's going to do it for our slides today with air pressure. Again, what I want to kind of stress here is make sure these things in your notes, especially this slide. I'll just kind of go through and say what you want in your notes. You want in your notes that's going to be high pressure represented by the H and low pressure represented by the L. You want low air pressure. You want to talk about the type of weather associated with low air pressure, type of weather associated with high air pressure. That air pressure is measured by a barometer. That when temperature, when water content or humidity or elevation increase, air pressure decreases. And you want to talk about more dense air is going to give you higher air pressure, less dense air, lower air pressure. And then you want to talk about what air pressure is. So make sure all those things in your notes. Again, as always, if you have any questions, feel free to reach out to me and I'm happy to help. So I hope you liked this video and good luck on completing this week's assignments.